time graph. maanta waxaan qaadan doonaa casharka labaad velocity time graph. Introduction. Distance time graph. Distance waxaan ku qori jirnay vertical axis, horizontal axis kana waxaan ku qorinay time in seconds. Time in seconds. Now conversion graph, we want to convert 72 kilometers per hour to meters per second. From kilometers per hour to meters per second, and from meters per second to kilometers per hour. This one you divide by 3.6. That is the simplest way of answering that question. Meters per second to kilometers per hour, you multiply by 3.6. The first one, 72 kilometers per hour. 72 kilometers per hour to meters per second. We divide this one by 3.6. So therefore 72 divided by 3.6. You multiply both sides by 10, and then you get 720 divided by 36. If you divide by 36, 1 by 36, you get 2, then you get 20 meters per second. B, 50 meters per second to kilometers per hour. We said from meters per second to kilometers per hour, you multiply by 3.6. So therefore 50 multiplied by 3.6, 0 cancels the point. So therefore you get 36 multiplied by 5, that will be 0 carry 3, 180 kilometers per hour. Kilometers per hour. So that is the introduction. Yesterday's work. Today's lesson is lesson 2.2, velocity time graph. Velocity time graph. Learning outcomes. By the end of the lesson, learners should be able to interpret and use graphs in practical situations. Interpret and use velocity time graph, interpret in real life situations. Velocity time graph, velocity is written on the y-axis, and on the x-axis you write the time. Velocity time graph, key things to remember. The gradient of the line is equal to the acceleration. The flat section, this is what I mean. So this is velocity, v meters per second. This is time, seconds. Let's say a car moves constant speed, and then that is rest, and then this is return. So this one is constant. This is constant acceleration. This is state of rest, that is stationary there. And this one is known as the deceleration. Deceleration, or we can as well call it retardation or negative acceleration. Now the gradient of the line is equal to the acceleration. Gradient, we mean when you want to find the gradient, you pick any 2 points on the line, and then you divide change in v divided by change in t. So that is acceleration. A will be equal to dv divided by dt. dv divided by dt. You can pick another point, and then you still get constant constant acceleration. Constant acceleration. So the gradient of the line is always equal to the acceleration. The flat section means no acceleration. The flat section is here. So this one is the acceleration is equal to 0. The gradient of any horizontal line is always equal to 0. And then the negative gradient means this side. This side. So this one is the gradient, the acceleration is negative. Therefore, this one means returning to start. Returning to start point or coming back. This backward is known as deceleration or retardation or negative acceleration. Example number 1. Example number 1 reads, a cyclist starts at rest and accelerates to a speed of 5 meters in 2 seconds. He then travels at a constant speed of 5 seconds, coming to stop in 3 seconds. Now the question is, draw the speed time graph of the journey. Now, we are told a cyclist starts at rest. We want to draw that. This is the rest position, time is 0. So the cyclist starts at rest and accelerates at the speed of 5 meters. So this is the speed or the velocity, which is 5 meters per second. So this is where 5 meters per second is. Time taken is 2. So this is 2 seconds. He then travels at constant speed for 5 seconds. So that is 5 seconds. Constant speed, 5 seconds. So 2 plus 5 is 7. So that is 7. At constant speed for 5 seconds before coming to stop in 3 seconds. So you add 3 seconds, that will be 10. So this particular point is 10. So that is the graph for that. The question number 1 reads, draw the speed time graph for the journey. So this is the speed time graph for that journey. Calculate the acceleration of the cyclist during the first part of the journey. The acceleration for the first part of the journey, that is the first 2 seconds. The first 2 seconds, this is our initial. So acceleration here is equal to change in y divided by change in x. So acceleration is dv divided by dt. So therefore you have 5 meters per second divided by 2 seconds. So the answer will be 2.5 meters per second per second. 5 meters per second, or you can call it 2.5 meters per second squared. Meters per second squared. Calculate B, this was A, B, C. Calculate the total distance the cyclist traveled over the journey. The total distance. The total distance, we said total distance is equal to always area under the curve. Area under the curve. So the total distance, you can do this in 2 different ways. We can split this into 3 sections. The first section is A, that is a triangle, a half base multiplied by the height. The height is 5. There you get 5. B, you have if you subtract these 2 points, you get 5, and then multiplied by 5. That will be 5 multiplied by 5. You get 25. And then C, will be this triangle. So that will be a half base, which is 3. 3 means 10 minus 7 is 3. And then multiplied by the height, which is 5. You get, this is 1.5 multiplied by 5, you get 7.5. So total distance will be equal to the addition of this. So that will be 5 plus 25 plus 7.5. You get 30 plus 7 is 37.5. And then meters. That is example number 2. Below is a speed time graph of a track cyclist during a race. Work out the total distance traveled by the cyclist over the course of the race. So let me draw that diagram again. So that point is up to 15. There you have 10. And then you have 5. Backward is up to 5, up to 10, I'm sorry. And then there we have 20. And then constant speed. Constant speed. So there you have 10. This is 15. 15. This particular point is 20. And then the last part is 50. Now the question is, calculate the total distance. We said total distance is always equal to area under the curve. We can do this one again in 2 different ways. Let me start with the first method, M1. M1 will be, we divide this into 3 sections, call these A, B, 4 sections, A, B, C, D. A will be a half, that is area of a triangle, that is base multiplied by the height, which is 15. There you get 75. This is A. B, this is the shape of a trapezium. So this one, if you flat this one becomes, this will be the height, and this will be the parallel sides. So that will be, the height is 5, bracket A plus B, this 10 and 15, 10 and 15, and then this will be equal to half, multiplied by 5, multiplied by 25, you get 2.5, by 2, 1 by 2, you get 2.5, times 25, you get 62.5. See? This is another trapezium. These are the parallel sides. A half multiplied by, this is 10. The height is 5. And then the parallel sides will be 10 and 20. 10 and 20. Therefore, we get a half multiplied by 5 multiplied by 30. By 2, 1 by 2, you get 15 times 5, you get 7.5 again. That is 7.5. Then lastly, that is a rectangle. You subtract these two, LB. This is LB. So 30 multiplied by 20. 30 multiplied by 20, you get 600. So total distance covered will be 75 plus 62.5 plus 75. And then plus 600. You get, that is 137.5. 137.5 plus this one will be 212.5 plus 600. You get 212.5 plus 600. You get 812.5 meters. So this is the first method. Method 1. Method 2. Method 2 for that one, you just complete the diagram This one becomes a rectangle. And then we shade this region. We shade this region. So let's find the area of the shaded region. Area of the shaded region will be equal to area of the rectangle, area of rectangle minus area of the unshaded part. Area of the unshaded part. So area of the rectangle is 50 multiplied by 20. 50 multiplied by 20, you get 1,000. And area of the unshaded. Area of the unshaded part, we subdivide this one again. That one becomes A, which is a trapezium. And this one is another trapezium. And this one is a triangle. So the first one will be a half multiplied by, these are the parallel sides, 20 minus 5. 20 minus 15 is 5. So the height is that distance, which is 10. So we have 5 plus that total distance, which is 20. From the origin to this particular point is 20, so these two are the parallel sides, and this one becomes the height. So by 2, 1, by 2, 1, I mean by 2, 1, by 2, 5, 5 times 25, you get 125. The next one, area, that is B. B is, this is 5, and this is 20 minus 10, that is 10. So a half, the height is that small distance, 5, bracket. So this will be, this is 10 plus 5, 10 plus, so this is 10 plus 5, yes. That will be 15. A half multiplied by 5 multiplied by 15, you get by 2, 1, by 2 you get 2.5. 2.5 multiplied by 15, you get 5, 2, 5, 12, you get 5, 7, and then 3, that was 7.5. That's 7.5. So total area of the unshaded, total area of the unshaded will be, we had 1, 2, no, what is remaining is the triangle, C, a half base multiplied by the height. That small distance is 5, and then the height is 10. So by 2, 1 by 2, you get 5 times 5, you get 25. So total area of the unshaded is 125. 125 plus 37, you get 162.5. 162.5 plus 25, you get 187.5. 187.5. So you subtract. Area of the shaded region will be 1,000 minus 187.5. Area of the shaded region will be equal to 1,000 area of the unshaded region, area of the shaded region, I mean, area of the shaded region is 1,000 minus 187.5, you still get 812.5 meters. So that is the second way of doing that question. Second way of doing that question. Now question number 3, the graph shows part of another journey, and then the lorry accelerates and then travels at constant velocity. State the relationship between acceleration, change in velocity, and time. Now the graph looks something like this again. It starts from here. This is 4. We have 8 there. And then up to the last point, which is 16. this is meters per second, and this is time. So 2, 4, 6, and then 8, time in seconds. To accelerate up to that point, up to that particular point, and then moves at constant velocity. Constant velocity. So the question is, state the relationship between acceleration, velocity, and time. Acceleration, the relationship is acceleration is equal to change in velocity divided by time taken, change in time, that is. Change in time. So velocity, which is meters per second, divided by second, you get meters per second squared, or meters per second, or meters per second squared. So this is the change in the relationship between velocity, acceleration, and time is acceleration will be equal to change in velocity divided by change in time taken. Calculate the acceleration of the car in the first 6 seconds. The first 6 seconds, this is where 6 is. This is where 6 is. That is where 6 is, in the first 6 seconds. So that distance. So this is where each square unit, there are 5, so each square unit, that is 6. This particular point is 6. Up to there. So change in velocity, acceleration is equal to dv divided by dt. dv, we have 6 and 16 and 6. 16 and 6. Change in time is also 6. So there you have 6 minus 0, that is, which is equal to 16 minus 6 is 10. 10 divided by 6. By 2, 3. By 2, 5. This will be equal to that will be 1.67 meters per second squared. Meters per second squared. Number 4, the speed time graph shows 50-second car journey. Find the section of the graph that has the greatest acceleration. The greatest acceleration. The greatest acceleration. It's like this. Greatest acceleration, we have 10, 20, and then we have there 30, and then 50. This particular point is 15, and the last part is 25. So the greatest acceleration, we only find the acceleration of these two parts. So this will be acceleration is change in velocity divided by change in time. Change in time. So velocity, there we have 15 minus 0 divided by 10 minus 0. You get 15 divided by 10, and then this is 1.5 meters per second squared. Then the next one is acceleration. The distance from 15 to 25 is 10. So dv divided by dt. So that is 10 divided by, so this is also another 10 divided by 10, you get 1 meters per second square. And the other one is, this one is negative acceleration. A will be equal to the distance, that is 25 minus 0, and this is 20. By 5 is 5, by 5 is 4. You get 1.25 meters per second squared. So the greatest acceleration is A. A has the greatest acceleration. A has the greatest acceleration. Marka intaasaan ku joojinayaa exercise-ka